Hello everyone, I am Jani, a third year electronics and communication engineering student from National Engineering College, Kovilpatti. I am really excited to present my internship project titled IoT-based Home Automation System, which I developed during my internship at Emertxe Technologies. In this session, I'll be sharing what I learned during the internship, how I applied the concepts of C, C++, embedded systems, and IoT and how I implemented my final automation project using Arduino, PICSimLab, and the Blynk IoT platform. This internship was a very enriching experience that gave me both theoretical understanding and hands on practical exposure. We started by learning C and C++ programming, which helped me to build a strong base in programming logic and structure. Later, we explored embedded systems, learning how hardware and software work together inside smart devices. Then we moved on to the IoT, where I learned how everyday devices can be connected and controlled through the internet. Finally, we applied all these concepts to create our own project, an IoT based home automation system. This project really helped me understand how to connect sensors and write control logic and use IoT platforms like Blynk to manage devices remotely. Here is the timeline of our internship. Our internship was well structured and each day focused on a specific topic. In the first week, on day 1, we learned the basics of C language like data types, number systems, data representation, and modifiers. And day 2, control statements we are studied in sign modifiers, decision making statements like if else switch, and looping structures for while do while. On day 3, we are find the operators, arrays, and jumping statements, understood different operators and array handling. On day 4, we are explored function creation, parameter passing, and the concept of pointers with call by value and or references. In remaining the day 5, we have learned advanced pointer concepts and how to pass and return arrays using pointers. On day 6, we are studied various pointer types, string handling in C, and different memory segments. On day 7, we are understood storage classes and processes, directives for macros, file inclusion, and conditional compilation. On day 8, we are gained the knowledge on object oriented concepts like OOPS, classes, objects, access specifiers, and constructors. On day 9, we are explored destructors and OOP principles such as encapsulation, abstraction, inheritance, and polymorphism. Throughout the internship, I learned a lot, not just theory, but practical concepts too. I understood what IoT and smart systems are and how to use Arduino to build them. On day 1, we are see about understood project objectives, identified required components, and designed the basic circuit and block diagrams. On day 2, we learned to IoT fundamentals, its components, and real world applications like smart homes and irrigation systems in agriculture. On day 3, we have studied the basics of embedded systems, compared microcontrollers and microprocessors, and explored the Arduino architecture world. On day 4, we are interfaced the LED with Arduino and wrote code using digital pins and delay to blink the LED. On day 5, we are learned to interface a 16 cross 2 LED LCD with Arduino, understand pin configuration and displayed data using code. On day 6, interfaced LM335 THT11 sensor, read temperature data and displayed the output on the serial monitor or LCD. On day 7, we are explored PWM concepts using analog write for applications like LED brightness and motor speed control. And the other, we have implemented serial communication with Arduino to monitor water levels and display readings on the serial motor, which are wanted for the home automations. And the we are Blynk app integration will also do that. Connected Arduino with the Blynk IoT platform to control and monitor devices remotely via a mobile app. We can see the update notification in the Blynk app. Throughout this internship, I learned a lot, not just theory but practical concepts too. I understood what IoT and smart systems are and how to use Arduino to build them. I worked with sensors like LDR and LM35, which helped me to understand how environmental data is measured. I also practiced serial communication for data transfer between devices. Integrating the Blynk app was my favorite part because it allowed me to control and monitor everything directly from my mobile phone. And we also used PICSimLab for simulation, which made testing easy without using actual hardware. Overall, these skills gave me a clear idea of how embedded systems and IoT work together in real life application, not I even know in my real life. Here, the first one we are going to see about Internet of Things means IoT. It refers to a network of interconnected physical devices that can collect, exchange, and act on data through the internet without requiring direct human intervention. These devices called smart objects that include sensors, microcontrollers, home appliances, and industrial machines that communicate with each other to create intelligent objects. In smart homes, it helps control devices like lights and fans from anywhere. In healthcare, IoT devices monitor patient health continuously. In agriculture, also, farmers use IoT systems for automated irrigation and soil monitoring. In industries, IoT is used for machine monitoring and predictive maintenance. We also see IoT in smart cities, transport systems, and environmental monitoring. So, whatever automation and data communication are needed, IoT plays a key role in that. Now, coming to embedded systems, an embedded system is basically a combination of hardware and software designed to perform a specific task. For example, washing machines, ATMs, and routers are all embedded systems. They usually have a microcontroller, some memory, sensors, and output devices. They are small, reliable, and perform real time operations in the real world. In my project, the Arduino acts as the embedded controller. It reads sensor data which I provide, processes it, and sends commands to turn devices on or off by its commands. So, embedded systems are really the brain of most automation projects which are implemented in the real worlds. Here, the Blynk app is one of the best tools for IoT projects. It's a mobile platform that lets you control and monitor your hardware devices through the internet. The app has a single drag and drop interface. You can add buttons, sliders, and gadgets to control or view data in real time. It connects to the hardware through the Blynk cloud using our Wi Fi. In my project, I used Blynk to control the heater, cooler, inlet, and outlet walls of my tank, and also to display the temperature and water level. It made my project look professional and interactive with that, just like a real smart home system for my project. Here some applications of Blynk app. The Blynk app has a wide range of uses. It's mainly used in home automation projects where user control appliances remotely from their phone. In IoT based monitoring, it displays live data like temperature or humidity. In industries, Blynk helps in monitoring machines and sending alerts when something goes wrong. It's also used in agriculture for irrigation control and in healthcare for patient monitoring. Since it's simple and open source, it's perfect for students and beginners to quickly create working IoT projects without complex coding. It's very important to learn about that. Here is the Arduino IDE. Arduino IDE is the main software used to write and upload programs to the Arduino board. It supports C and C++ and has a very easy interface for beginners. The best part is the serial monitor, which allows us to see live data from sensors or print debug messages when the code is wrong. It also provides libraries and example codes, which made my project development much faster. Using the Arduino IDE, I was able to write logic to read sensors, control devices, and communicate with the Blynk cloud. So, overall, Arduino IDE acted as the programming environment for my entire IoT system. Here, the next one is PICSimLab. It is also in our internship part. PICSimLab is the real time emulator of development boards with integrated MPLabX or average ZBD debugger. The simulator which we used to implement the programs in our project is PICSimLab with Atmeha 328p Arduino Uno board. We upload our program in the format of .hex file in the PICSimLab simulator and we run it, and the output is observed according to the paths used. Here in the file we can see our project .hex file, and we are run and simulate. We can see our output in the monitor. Now let's talk about my final project, the IoT-based Home Automation System. The main controller here is the Arduino board, which communicates with sensors and the Blynk app. The LED sensor, LDR sensor controls garden lights automatically based on sunlight. The LM35 sensor monitors temperature and controls the heater and cooler. The serial tank module checks the water level and operates inlet and outlet valves accordingly. All the readings are displayed on the LCD display and the Blynk app in real time on the phone. This project shows how automation can make homes smarter, safer. Here you can see how the Blynk app interface looks in my project. I created different buttons to control the heater, cooler and valves. Cause widgets display the temperature and water level in real time. Whenever the temperature crosses a threshold or the tank gets full, a notification appears automatically on the terminal widget which is on the phone. For example, if the temperature goes above 35 degrees, the heater turns off and a message pops up saying heater turned off, temperature limit is reached. This shows how IoT enables real time automation and makes the system intelligent in our real life. Now let's move to the project demonstration part. This is the Arduino IDE user interface. I created separate files for each component. This main file contains the Blynk template ID, device name, and authentication token received when registering the device on the Blynk IoT cloud platform. Here we include preprocessor directives required for Ethernet cell temperature system and serial tank modules also. There's a function for the cooler pin and another one for the heater, both displayed on the Blynk app for control. Then the outlet and inlet valve function handle serial tap water flow. The update also the temperature. Next, the update temperature reading function updates real-time temperature on the display. When the temperature exceeds 35 degrees Celsius, the heater is automatically turns off and send a notification via Blynk app in the handle tag. In the handle tank function, we manage water column also here. If the water level drops below 2000 liter, mm, if the water level drops below 2000 liter means the inlet valve turn on automatic because it below our function. When the tank reaches 3000 liter, it closes automatically, ensuring that smart water management the setup function. Now the setup function runs once to initialize modules and the other one for loop function repeatedly call these subsystems for the continuous operation. Then the next file is for the is to garden light control. Is that here is the for garden light control. Here this is the function. This is the next file. Here is used for the garden light control. It includes functions to initialize and control garden light, brightness during the day and brightness decrease at night. It increases all managed using our LDR sensor here used. We also have the header file defining macros for sensor pins and constants. Similarly, the serial tank code initialize state tanks, volume, and control inlet outlet valve. Now, here is our function. Full module is that. Now, let's move to the these are the files. All the are the separate files. Here we are see the different files for each codes, temperature, water tank levels, and for all. So now let's do the project demonstration part. First I compile the code in Arduino IDE using sketch export compile binary. Once compilation is successful, I open PICSimLab, the compile.x file and run the simulation. Here you can see the Arduino Uno board with its connected components. CLCD is this is CLCD is character LCD displaying current temperature around 27.34 degrees Celsius and serial tank volume. Here is the serial tank volume just approximately 30 liter in the LCD. Then LED sensor and LED managing garden light Ethernet seal providing internet connectivity, and then temperature control system with LM35 sensor. Here we can see the whole system of that. It's shown in that one for heater, two for cooler, and three for temperature. Now connect. Now let's see how I will show you my how my smartphone connects through the Blynk IoT app. The app has two tabs. The tab 1 cooler button, heater button, temperature go and notification panel, and the tab 2 is inlet wall control and outlet wall control for the tab. Here I will turn on the heater which measures the real-time temperature which given by the PICSimLab sensor. Then turn off the heater, then turning off the cooler also. Then inlet wall control and outlet wall control. Currently the temperature is 27 degree. Here is the 32 to 27 degrees changes in the tank wall. Thus all things, here we can see the temperature is modified here from 32 to now it's become 27 degrees Celsius, and the volume of tank is 3000 liter. Now the all things work smoothly. Here the tank is volume is come When I press on button, the tank becomes full. Here we can see the increase in the tank wall. After full filling the tank, they give the notification. Here the tank is becoming full here. After fulfilling the tank, they give the notification. Here the notification has come. Please turn off the tank. So this is our demonstration part. To conclude this internship and my project was a very valuable experience for me. I not only learned programming in C and C++, but also got practical exposure to Arduino, IoT, and embedded systems. Building this project helped me to improve my problem solving, debugging, and design skills. It also taught me how to work systematically, from planning to coding and testing. I learned the importance of documentation and project organization. Overall, the internship has really boosted my confidence and motivated me to pursue a career in embedded systems and IoT development. I also got a very big knowledge in C and C++, Arduino, IoT, and embedded systems with this internship. Thank you so much for listening to my presentation. I would like to thank Emertxe Technologies for this wonderful internship opportunity and for their constant support and encouragement. This experience truly helped me grow both technically and personally myself. Thank you once again.